Okay, this has a couple different aspects to it. So this is a Hess's law problem with a couple different twists to it. So it says, given the following equations, so we still have some given equations. And then it says, using these two equations, determine the heat of formation for nitrogen monoxide. You might say, well, they didn't even give us an equation. Well, remember the definition of the heat of formation is to form a compound from its elements. So in this particular case, you have a compound that has some nitrogen, you have a compound that has some oxygen, but I'm not going to say N and O. I'm going to form this compound by N2, and the standard state of N2 is a gas, and O2, the standard state of O2 is a gas. And I'm going to form nitrogen monoxide gas. Now here's the tricky part. In order to be enthalpy of formation, the coefficient for NO has to be 1. That makes the coefficient for nitrogen 1/2 and oxygen 1/2. I'm going to say to myself, eesh, can you imagine using fractions? Whenever we're in a situation where we have to divide or use fractions, sometimes that can be tricky for people. I know myself, I'm better off not using fractions. So you can either multiply it by 2 so that we don't have the fractions to start with, but then we're going to have fractions in the middle because I can see that already. But if I multiply this by 4, it's going to save me some issues. So let's see what that looks like. If I multiply it by 4, it's going to be N2 plus 2O2 gives me 4NO. The reason I'm doing this is it will allow me to do the entire problem without fractions, and then the last step I'm going to do is to divide by 4. So we multiplied by 4 to get to this, and we will divide by 4 as the last step. So we're going to number our equations just like we were doing, 1 and 2. And I'm going to say, oh, I've got nitrogen in the second reaction, except the problem is nitrogen is in the products. I need it in the reactants. So I'm going to flip the equation, and that means I'm going to change the sign of the enthalpy. So this is going to take my equation here, and my products are going to become my reactants, and my reactants are going to become my products. So that's 6H2O plus 2N2. Notice I'm leaving the states of matter off, which is fine because I can see that none of the states of matter of any of the compounds change in the middle. If they don't change, you don't necessarily have to write them every time. I'm going to skip over. I've got nitrogen where I want it right now in the reactant side. I'm going to skip over oxygen because you can see that it's in both equations, so it's going to be a little trickier to figure out, and they usually end up falling in place in the end anyway. So let's go over to NO. NO is in the first equation. It is a coefficient of 4, so I don't have to change anything. I just rewrite it. Now That gives me 4NO where I need it. Let's make sure that the things I don't need cancel out. They can only cancel if you have one on the reactant side and one on the product side. Now let's look at our oxygens. I have 3 oxygens here that don't cancel all 5 of these. They leave me with 2. So let me rewrite this. 2N2 plus 2O2 gives me 4NO. And my enthalpy is going to be 1530 minus 1170. But remember, the first thing we did was multiply by 4. So the last thing we're going to do is divide by 4. So that'll give us 1/2 N2 plus 1/2 O2 yields NO. And my enthalpy is also going to have to be divided by 4. And I get a positive 90 kilojoules. Ta-da.